This is a plastic model of a dividing head, and its job is to divide a circle up into even parts. It can be used several different ways. If I turn the crank on the back here, is called simple or plain indexing. If I rotate the spindle, it can do what's called direct indexing. I can also use the crank handle to do angular indexing, or I could do differential indexing. If I turn the crank handle here, what it does is it turns a bevel gear on the bottom of this crank handle, which turns the shaft on the bottom, rotating the worm. I'll reposition the camera in a minute to see that, which turns the worm gear. Now each revolution of this crank handle will move the shaft on the bottom one revolution, which causes the gear that it's mated with to move one of the number of teeth. This particular gear has 40 teeth on it, so what we have is a 40-to-1 gear reduction for simple or plain indexing. Here's another angle of the worm and the worm gear in mesh. Again, if I turn the crank, you can see the worm starts to spin, which drives the worm gear on top. And this is causing that reduction. This will cause the chuck to turn, which is on that shaft on the top, which is the spindle. Dividing heads provide a device so we can actually drop the shaft that the worm is on if we don't want to use that 40-to-1 reduction. So if we just drop that worm shaft out of the way, now we have a 1-to-1 gear reduction. In other words, I can just rotate the chuck, and the spindle of the chuck will make one complete revolution. So we have a 1-to-1 reduction when that worm is dropped. This is the principle that the dividing head actually works on. Here's an actual dividing head set on a milling machine table, and you will notice the hole plate and the crank pin on the front with that 40-to-1 gear reduction at the chuck. So if I turn this crank pin, what happens is it will turn the chuck. So I'll end up pulling this out and the chuck is turning. That's because the worm is actually engaged. On the back side of this particular dividing head, we actually have a mechanism that if we unlock it, we can actually drop that worm from the worm gear so it's not in rotation. So I'm just going to take a wrench and loosen this nut, and now I can actually swivel it out of the way, and I'll tighten the nut so it doesn't accidentally engage again. Back to the front side of the dividing head again. If I turn the crank, you can see now there is nothing happening at the chuck. So what we have to do in order to turn the chuck is we actually have to grab a hold of the chuck of the work holding device and we can spin it. Now there's a shaft that runs right through the dividing head on this chuck, and either just in behind the chuck or on the back side of it there will be a direct indexing plate. In this case it's on the back side, and it will be one of three particular plates, either a 24, a 30, or a 36 groove holes. So we're looking at the back side of the spindle now, and this is that direct indexing plate I was talking about. If we actually undo this nut, we can change it. This particular one is 24 groove. Again, it could be a hole. So it's a direct indexing plate. They also make them 30 and 36. These will come with your dividing head. And if I rotate the chuck by hand and I line it up at 0, now I'm just going to drop this lock down in so there's nowhere it can go, and we're ready to start cutting the first flat. In this case, what we'll do is we will make 4 flats. So there's 24 grooves on the back of this plate. So if I divide 24 by 4, I should move 6 grooves for every flat in order to make a 4-sided shaft or a square shaft. With that direct indexing plate locked into the 0 position, we're now ready to start to cut this part. So we brought the camera around to the front side where the work holding device or the chuck is, and we're ready to fire up the milling machine and cut the first flat. So milling machine's on. We're just going to move the table to cut the first flat. Because we have to get our hand in next to the chuck, we'll make sure that that spindle is shut off, and you can see we now have one flat. We'll take you back to the back of the dividing head again, and we will move it around so we get the next flat. So we're ready to move this to get the next flat, so we're just going to release the lock, and what we'll do is we will count 6 spaces. We never ever count the space we were in. So 1, 2, 3, 4, 5, 6. Again, 24 divisions divided by 4. So that'll end up being 6. The number in the math you work out needs to be a whole number. If it's a fractional number, you cannot use direct or rapid indexing. So here we go. 1, 2, 3, 4, 5, 6. We'll drop this back in, make sure it's secure, and we're ready to go again. We'll take the camera back out front. Okay, so here we are ready to cut that second flat. So we'll turn the milling machine on, and we will move the cutter through the part. And again, we'll shut the milling machine off. Index the direct indexing plate around 6 more grooves. 1, 2, 3, 4, 5, 6. Drop it back in. Lock it in place. Come back around the front. I think this time I'll try and move it with the camera, see what happens. Turn the milling machine on. Run the cutter through the part. Machine off. This time I think I'll just move the direct indexing plate by hand without moving the camera back, so you can see what's happening on the front side. Again, 6 divisions. 1, 2, 3, 4, 5, 6. Drop the lock back in, and this should be our last flat for our square on the end of the shaft. And all we need to do is clean this part up, and it is good to go. We have a flat. The width across the flat will be determined by how high the table is moved up or the cutter is moved down into the part. Again, this is direct indexing. We have a 1-to-1 ratio because we've dropped the worm from the worm gear, so they're no longer in rotation together. And we are using direct indexing plates which are bolted to the back of the spindle. In this case, it's a 24 division direct indexing plate. We also could have used a 30 or a 36 division. The number of grooves in the whole plate, in this case 24, is divided by the number of flats machined. In this case it's 4. So 24 divided by 4 gives us a whole number of 6 divisions. We cannot use a mixed fraction. It has to be a whole number. If we have to use a mixed fraction, we have to go to what is called simple indexing. Thank you.